All right, so cross multiplication. We should hopefully be masters of that. Otherwise known as the butterfly method. That's what you guys were calling it?
What's a butterfly?
All right, so now we're going to do some manipulations of proportions, because when we start moving through this chapter, and let's say that you guys, let's say that you're working with your buddy on these problems and you set up a proportion, then your buddy sets up a proportion, and you're like, well, your proportion's not the same as mine. You're wrong, I'm right. It may be the scenario where you're both right? Because we can manipulate proportions to keep true statements. So in section 6.2, we're going to talk about these properties of proportions. So your reciprocal property says, I think this is the part where you're filling in your notes, if we have a proportion such as A over B is equal to C over D, then it's still going to stay true if I take the reciprocals of both of those ratios. Right? So then it still is going to be true that B over A is equal to D over C. If we check our cross products, here I have a cross product of AD, here I have a cross product of BC. Over here I still have a cross product of AD, I still have a cross product of BC. In that first box. The top box. So really quickly, is 1/2 equal to 3 over 6?
No.
Yes. What are my cross products? 6 and 6. 6 and 6, right? Are your cross products? 6 and 6. If I take the reciprocals of those, do I still have a true statement? Yeah. Do I still have the same cross products? Yes. Okay. So reciprocal property allows you to take the reciprocal of them and you're okay. All right. The next one is if you interchange the means, it's your first fill in the blank, of a proportion, then you form another true proportion. So if we go back to our standard, bless you, if A over B is equal to C over D, I can interchange, these are called the means right here on this diagonal. So I can move the B up to here, and I can move the C down to here to get AC over BD. These are called your means, the means. So another way to look at it, this is how I see it. Can I make a ratio out of my numerators? And I make a ratio out of my denominators? And do my cross products change? Do I still have A times D over here? Yes. Do I still have B times C? Yes. So if I go and work off of this 1/2 and 3/6, if I make a fraction out of my numerators, 1 out of 3, make a fraction out of my denominators, does that still stay a true statement? Is 1/3 equal to 2 over 6? Yeah. Do I still have cross products of 6? Yes. Okay. So you can interchange means like that. And then the last one is in a proportion, if you add the value of each ratio's denominator to its numerator, then you form another true proportion. So if we have our original A over B is equal to C over D, then I can add my denominator of B to A, and I can add my denominator of D to C, and it's still going to stay true. So let's see how that works over here. So if I had my 1/2 equals 3 over 6, and I add my denominator of 2 to that numerator, and I add my denominator of 6 to that numerator, I now get 3 over 2 is equal to 9 over 6. Is that true? Are my cross products both 18? Yeah. So it's true, right? Yeah? So just different ways you can manipulate proportions. All right, so let's see if we've got this. So complete the blanks. If I had 8 over x is equal to 3 over y, and then 8 over 3, it would be equal to what over what? So what am I doing? I'm switching the means, or taking numerators over denominators. Good, so x over y. For the second one, if we have x over 8, what would the second ratio have to be? Y over 3, right? Because we have to keep the same cross products. Over here I had an 8y cross product, so that means I have to keep an 8y cross product over there. And then for the last one, good, 3 plus y over y. Nice. Okay? When you're done, flip onto the back so I know you're ready. Okay, so we're talking about fractions, we're talking about ratios, right? What are all the different ways that you can write a ratio?
One part.
So if I had a ratio of 1/2, I could write it as 1 over 2. Or we could write it as 1 to 2. Remember seeing that before? Have you seen the 1:2? Right? So there are different ways to write ratios. 1/2 or 1 to 2 or 1 to 2 with the colon. All right, so now let's start throwing some geometry into our life. So are we ready? Geometry problem 1. The ratio of the measures of the sides, so we're talking about the sides of a triangle, is 6 to 8 to 12. And its perimeter is 130 feet. I want to find the measure of each side of the triangle. So what does that mean? Just make a random triangle in that space there that you have. If I know that the ratios of those sides need to be 6 by 8 by 12, right now, if I didn't have anything else added to them, what would be the perimeter of that triangle?
6, 8, 12.
Well, so adding it together makes what, 26? Does that equal a perimeter of 30 feet? No. Okay, now just watch this, don't do anything. What happens if I doubled all these sides? Now do I get a perimeter of 130 feet?
Yes.
No.
Wait, no.
Nope. What if I tripled everything? Would I get it? Okay, so I could just keep doing, I don't even know what that is, 36. I could keep doing guessing and checking until I got it to work to 130. Or instead of guessing and checking, we can use algebra to come up with what that multiplier needs to be. And so whenever we need to use algebra, we like to use unknown variables, in this case, x. So please do this in your notes, because this is what you are going to do. So you're going to take your ratio. Because I am talking about perimeter means that we are going to add the sides, right? So I'm going to add 6x plus 8x plus 12x.
Oh, then we're going to set it equal to 130.
And then I'm going to set it equal to 130. So that gets us 26x equals 130. What is that? Is that 5? So x is equal to 5, which tells me what must the side lengths be. Well, what's 6 times 5?
30.
So 6 times 5 tells me I'm going to have a 30-foot length side. 8 times 5 is 40. So I'm going to have a 40-foot side. And 12 times 5 is 60. So I'm going to have a 60-foot side. So that triangle would have a perimeter of 130. If I reduced these numbers, it would all take me back to the 6, 8, 12 ratio. Okay?
Yeah.
All right. What if instead of perimeter, just for fun, let's get our brains going. What if instead of perimeter, it said that the measures of the angles of a triangle is 6, 8, 12? What would change in this equation? Noah? It would be 180 instead of 130 because I know all the angles should add up to 180. Good. Okay. All right, let's do the next one with area. The area, or the ratio of the length and the width of the sides of the rectangle. Okay, so rectangle, let's make a rectangle. The ratios are 4 by 5. I'm going to attach x's to them. Now we're told that the area, well, how do I find area of this rectangle? Multiply them together. 4x times 5x is equal to my total area of 1,620. Oh boy, what's x times x? X squared. So we get 20x squared is equal to 1,620. What do we get when we divide that by 20?
Wait, why is x squared?
Remember, x times x is x squared. Because you add exponents when you multiply. 81, I agree. So dividing out the 20, that says x squared is equal to 81. And we know from our practice that that's going to be what? 9. Technically, in algebra world, it's plus or minus 9. I don't care about the negative because I know that my side lengths can't be negative of a rectangle. So what are the true dimensions? 45 by 54. Forgot to add in my units. So put little feet
How do you
marks.
put the square root signs over? Yeah, what do you?
Because how do you undo a square? You take the square root. The square root of a square is just whatever that number is, the radicand.
So if it was like 4x, so I do 2x.
If it was 4x.
Or x4, I mean. Or
X to the fourth, then we would have to take a fourth root of it. Yeah, you have to do a cube root, a fourth root, a fifth root. Yeah, you do whatever root that exponent is. You'll do that in Algebra 2 next year. Okay?
We'll go like just square root or like just 4 roots.
Mm-hmm.
Actually,
Mm-hmm.
that's actually a thing.
Yeah.
8 roots.
Why?
Yeah, you can have whatever number root you want.
Why is that a thing?
Because why not?
What's a 4?
Oh, why?
All right. We're good with those?
Mm-hmm.
All right, let's talk about geometric means. So we just had that proportion that talked about that proportion manipulation where we are interchanging the means, which were these on the diagonal. So we have something that's called the geometric mean. So the geometric mean of A and B, so any number A and B, is the number x that satisfies the proportion of A over x equals x over B. So the geometric mean of A and B is the number x that satisfies A over x equals x over B. So then when we were to cross multiply that with our cross products, we would end up getting x squared equals AB. And then how do we undo a square? We take the square roots of both sides. So really all I care about is this right here. If I'm asked to find the geometric mean, all I really need to do is take the product of my two numbers and take the square root of it. That's the important part to remember. Why? Where does that come from? Well, it comes from this, because these are your geometric means, right? These are your means. You multiply them together to get x squared. Multiply these together to get whatever a times b is, and then you square root both sides, okay? So if you're asked to find the geometric mean of, let's say, 24 and 48, I'm going to take x and set it equal to the square root of 24 times 48. Now, we could take 24 times 48, which is probably some really giant number. What is it? 24 times 48, 1152.
How do you know that?
He's a human calculator in his head. So we could try to simplify that. Does that look like fun?
No.
No. So it might be easier to simplify these individually and then mesh them together. So let's do that. So the square root of 24, let's start there. What perfect square goes into 24?
5.
4, 6, no, 4 and 6, right? I was going to go 4, 6.
I said 5.
4, 9. So 4 times 6 is 24. the square root of 4 simplifies to 2 square roots of 6. That's not that bad, right? Let's do the same thing for 48. Perfect square goes into 48. Well, 4 does, but I think we can go bigger. 4, 9, 16. 16 does, doesn't it?
Mm-hmm.
16 times 3. So that goes to 4 square roots of 3. So now how do you think this is not the answer. How do we put these together?
You multiply them.
Multiply the 2 and the 4 together.
And then
So that gets 8. Multiply the radicals together, which would get you,
How do you get
18.
the square root of 16 is 4.
Oh, okay.
And then you're left with that. So this 2 and this 4 come together to make 8. The square root of 6 and the square root of 3 makes the square root of 18. I could be done, but I'm not. Why not?
Because there's a square root that goes.
I can simplify a square root of 18 yet.
No.
Can I? So 9 and 2. So that goes to 3 square roots of 2.
And then you would add the 3.
We would multiply the 3 with the 8. This is all multiplication.
So it would be 24.
So multiply these. Multiply. So it'd be 24 square roots of 2.
My brain
Is that the
hurts.
answer?
Yeah.
I lost you a while ago. I'm not gonna lie.
I lost you after the 4 and 3.
It would have probably been a much easier problem if it was find the geometric mean of, let's say, 3 times, I don't know, 8. Because that would just get us right to the square root of 24. Right.
Why do you do 3 times 3 and 2 times 8 and 18?
You multiply this 3 with that 8.
How'd you get 9 below that?
What perfect square divides into 18?
Yeah, but why
9. 9
Does he wanna
times 2 is
simplify it?
18.
Then why do we have a 2?
Why do you have it on the left?
And why is it 24 over 2?
Yeah.
Because I had, so this, all right, let me backtrack.
Because you want to get to the simplest.
So we had 8 times the square root of 18.
Yeah.
Well, the square root of 18 is the same as the square root of 9 times the square root of 2.
Right.
Bring down that times 8. Well, what is the square root of 9? 3. So now I have 3 times 8 times the square root of 2,
But then why?
which would get you to 24 square roots of 2.
Where did the 18 go? Did it just disappear?
Well, the 18 turned into a square root of 9 times the square root of 2. So maybe let me try it this way. So we had 24, and so we had the square root of 24 times the square root of 48 to start out with. Well, 24 is the same as 4 times 6.
Okay.
48 is the same as the square root of 16 times the square root of 3. Right? Well, where are my perfect squares? 4 and 16. So that turns into a 2. That turns into a 4. And then I'm left with a square root of 6. And I'm left with a square root of 3. So now this 4 and this 2 multiply to make 8. That root 6 and that root 3 makes root 18. But now I can go further with this. Because 18 is really 9 times 2. Which gets you the 8 times the 3 times the root 2. Which is your 24 root 2.
How'd you get 4? Oh wait, never mind. I thought that said 8, 4. Never mind.
Yeah.
I don't understand why we do 8 times 8 is 24. Then why wouldn't we do 2 times 18?
Where?
So you said 8, or what? Yeah, that. How we don't do
Well,
8?
because I turned the 18 into a 9 times 2.
But then we just dropped the 9 though, right?
No.
Well, no, the root 9 turns into a 3.
I don't think he gets the whole perfect square thing.
Because the square root of 9 is 3. The square root of 25 is 5.
Wait, what's the perfect square thing then mean?
Well, your perfect squares, are when you take the square root of them, end up being integer answers.
So like
Like the square root of 4 is 2.
Yeah.
The square root of 16 is 4. The square root of 81 is 9.
you use the perfect squares to get.
Oh, so like,
Simple.
the square root of the square root is the perfect square? Oh, okay.
Joseph?
How'd you get 24?
8 times 3.
Here?
Nah, down at the bottom.
8 times 3.
And then why can't you use like at the top? Why can't you use like 3 and 8 for 24?
you can do it. So you could have possibly in your Algebra 1 class just did factor trees and did 8 times 3. 3 doesn't go any further. So then you could have done 4 times 2,
I
2
never
and
did
2,
that.
and then you find your pairs. So it'd be 2 root 6.
I didn't even do anything.
I just find it easier to make it.
We just did the perfect square thing.
Yeah, that's what we did back when we did the distance formula. How easily we forget things.
Some people did do the tree
Really?
thing.
Yeah, same.
Yeah. All right, let's finish up. Let's do something really easy now. Are we ready?
No.
Ready to do something really easy?
I want to do something hard.
Yeah. Let's do the last 2 examples. You're going to be like, this is so easy. Here we go. So now let's take our proportions to a geometric figure. So in the diagram, we were given the following side lengths. Because remember, if we have 2 letters with nothing above it, that means we're talking about the length of that line segment.
Oh, so that would mean.
So we're given a proportion, and we're going to use the proportion with the lengths given to us to solve for an unknown part. So we are told that AB, and AB is over here, I think that's supposed to be a 6, is in a ratio with BC, which is down here, and I'll make it in red. And then AF I have in green, and then FD I'll make orange, is here. So what is the length of AB? 6. So I'm going to make a fraction of 6 over. What is the length of BC? I don't know yet. I mean,
So it
I
would
think.
just be BC.
Yeah, so we're going to put an X there for now. This one's a little bit easier to see. So we'll put an X there. We don't know what it is. AF is 12 over FD, which is 4. Can we solve that?
6 times 4 is 20.
So we got 24 equals 12x. So x is equal to 2. What did x represent?
BC.
BC. Is that what we were asked to find?
Mm-hmm.
So BC is equal to 2. Yeah? All right, so let's do the last one here.
Wait, but where's F?
I know, where is it? It's all right, so AB, how long is it?
Oh, wait.
12.
You did them in the wrong order.
I did?
Yeah.
Where's F?
No, I didn't. This is the second one.
No, because on this one it says AE, when on the other one it says AE. They're
No, the-
swapped.
Mine says AF.
Oh, I had the wrong proportion there. We got the idea of it.
Put like a little line at the bottom.
AE, and then this one says AF. Oh,
So 18.
so I just copied and pasted and didn't change it. There we go. All right, so AB is 12. What's BC? We don't know it, so let's make that X. Is equal to, oh, this should be AE. Does it say AF on yours? And it should be AE? There we go. Okay, so turn your F into an E. Is equal to 18 over, what's the length of ED?
Y.
No, I know that. We can find it. If this whole thing's 33,
Oh, so 32.
yeah, it's 15. 33 minus 18, so that gets us 15. So that gets me 18x equals 180. X is equal to 10. What did x represent? BC, which is what I need it to find, so BC is equal to 10. What if, instead of BC, it would have said find AC? Then what would we have to do?
Add 10 and 12.
Add 10 and 12 together
Which
to
is
get
22.
22. Okay. Alrighty. So maybe the hard